Yes, sir. Yes, sir. Yes, sir. You are audible. Very good morning.
Good morning, sir. How are you?
I am very fine. What about you, sir? All
Absolutely
well?
fine, sir. All well.
Good, 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 good.
Uh, Now it's already 10:33. हमारा आज का टॉपिक है बियॉन्ड स्ट्रक्चर्स इंजीनियरिंग हाई परफॉर्मेंस बिल्डिंग envelopes for a sustainable and resilient future by Dr. Architect Engineer S.P. Anchuri, sir. Dr. Anchuri is a distinguished architect, structural engineer, academician, and consultant with over 25 years of professional experience, a PhD in structural engineering, and a rare multidisciplinary professional with triple graduation and triple post graduation in civil engineering, architecture, structural engineering, management, and construction management. He has successfully delivered more than 2,500 projects across India. As chief consultant of Anchuri and Anchuri, he specializes in high performance buildings, sustainable design, heritage conservation, and the seamless integration of architecture and structural engineering. Professor Anchuri is a prolific speaker, researcher, and mentor who has delivered over 500 technical talks, presented more than 100 technical papers, and continues to inspire professionals through innovation, technology, sustainability, and future ready engineering solutions.
Sorry to interrupt, sir. Your voice is very low.
Oh, now is okay? क्या अभी वॉइस ठीक है?
Okay, please continue.
Can I read from start?
So it's okay. You can continue, sir.
You can just continue, please.
Okay. Presented more than 100 technical papers and continues to inspire professionals through innovation, technology, sustainability, and future-ready engineering solutions. Now I request to Dr. Anchuri, please take over.
Thank you, Yogaraj ji. Am I audible?
Yes, you are.
Yes, audible.
So let me share my screen first. My screen is visible?
Yes, sir.
Good. So thank you, ECI. Now, today I'm going to talk about beyond structures. We normally discuss about the structures and inner side. But we wanted to discuss something which is outside. So first of all, I would like to welcome to my talk and namaste everybody, because there is a cross section of the construction industry. What I'm seeing is all very eminent people have joined. So once again, namaste. In fact, from Pan India. So the engineering high performance envelopes, what it will be, and today we know the building should be climate responsive, energy efficient, and resilient, future ready, healthy enclosures, which can be a sustainable future. And in fact, friends, the building envelope is the first engineering system that depends, and that building performance depends on that. So envelope is a very, very important thing. So good morning once again. Today we look beyond the classic boundaries of steel and concrete and load-bearing skeletons. While safety is not compromising or non-negotiable, our climate contest depends or demands active environmental performance. So let us analyze how that governs and how that particular system is synced with all other systems. So my presentation is a little different than a regular routine, regular pattern. So I'm trying to put in a different format. I hope you all will like it. So here I go. Friends, the nature is that what we see. When you look towards something, naturally, with your eye is same, but your perception will be different. Now, when it comes to the natural environment, which refers to all the livings and non-living things that occur naturally on the earth with little to no human alterations. How it goes, in fact, when you think of the built environment, which comprises of so many things, in fact, the human activity, it's a, and basically I'm talking about today is a man-made world, which ranges in the scale from personal shelter to the buildings to large-scale infrastructure, cities, and transportation works. When it comes to the built environment, buildings are the predominant. So how we need to integrate, how we need to think as a collective approach that we will discuss today. Friends, there are several types of, as I say, how you see and with what we see. For example, just what you can see on the right side, a beautiful cable bridge. But when you see, it's excellent. But when you go closer to it, naturally that finish is different. For eye, it's good, but if you go closer, it's not so. So these structures, basically the infrastructure structures, are called as isotopic structures. But when it comes to the buildings, we have several types of elements in it. So when it comes to the exterior, which is normally I call as an enclosure or envelope, so they are all telescopic. We go little closer. Bridges will be at distance, dams will be at distance, and some structures will be at distance, but buildings are very near. So those things are called as per the telescopic structures. Now, when it comes to the interiors, we are very close to it. The intrinsic work which is involved. So we have eye or a watch on the detailing of that. So detailing is very important. So for these things, I call that as a microscopic works. And when it comes to the very, very important structures, like whether you see it, whether you don't see it, whether it's seen, they're all very important. That may be like a nuclear or hydroelectrical or atomic energy systems, or when these things are made, they are very, very important. For me, those things are nanoscopic. But friends, when we go back, 1,000 years back, 2,000 years back, some 2,500 BC, where the master builder who was the responsible person for everything, right from the planning, right from the designing, right from the construction or execution, and the operation and maintenance. Entire life cycle was under one person who was called as master builder. That may be temple. Like you see this, carved structure at Ajanta, Ellora, Hampi, Badami, or even if you say Mahabalipuram, these things are what scoping. Whether it's isotopic or telescopic, nanoscopic, that I need to decide. So everything they were thinking in a nano level. So we need to understand this. But tomorrow, when I'm talking about the today and tomorrow future, entire thing is taken over or taking over by the mechanization, automation, artificial intelligence. That is, we are talking about the 3D printing, robotics. The other day, there was one post was very viral that one doctor is sitting in one country and he's operating in another country in the home. That hospital theater, operation theater. So he's live about the medical engineering, but to what extent we have gone. So artificial intelligence, natural intelligence, and human intelligence. We have to come together. It's not, even if he's sitting there, he has to operate. Means human intelligence is above artificial intelligence, subjected the person who knows the artificial intelligence, naturally they will have more of a command, more of a result oriented. So where we are going. Friends, for everything, whether I am designing, whether right from the M.F. Hussain to the modern, paintings, whatever. So, I think for me, the design is to design a design to produce a design. And design is the ability to imagine that which does not yet exist, to make it appear in rigid form as a new, purposeful addition to the real world. Friends, designing is to initiate change in man-made things. And engineers have a very, very important role. And when I say engineer, they're not civil, mechanical, electrical. There are more than 20-25 streams. And I'm happy that I'm a part of Engineering Council of India as a member and PE, where all these people, different stakeholders come together and building the nation. Friends, when we started about 25, 30 years back, I think the disciplinary approach was more. Instead of cross-disciplinary or multidisciplinary, interdisciplinary, the discipline, they used to concentrate on their own disciplines. But today, as the advancement, as the industrialization, every sector is developing. For example, building information modeling or any automation, everybody has to come together. It's not in isolation, or we can't work in silos. But today, due to this new generation thinking or the future scope designs, the multidisciplinary or interdisciplinary is also a little lacking. So what we need is a transdisciplinary. We need to know what for you are doing, when you have to do, and how you have to do, and what thing goes behind the thinking process of that particular thing. I think we need to understand that, then only we can come up with the vital results. That is what transdisciplinary. And what is that transdisciplinary? In my understanding of transdisciplinary, is that of conceptual frameworks that are adopted as a wider perspective within the research and practice. Even though they may be having the different origins in one discipline, they have grown to be used across the multiple others. So we need to understand transdisciplinary, and I practice this about a decade now, and I produce or I bring out the buildings or built environment. Basically, I am into the building sector. So we can see how the transdisciplinary concepts can be utilized to make those buildings high performance. In fact, the evolution of construction material, architecture, and engineering, friends, increase the design complexity, height, and sustainability. We need to understand these things. When you started from the Stonehenge, now ancient civilization, medieval, Renaissance, industrial revolution, and modern era. But today we are talking about the low carbon concrete, recycled materials, eco-friendly designs. Just imagine if you go back hundreds and thousands of years back, we were sustainable. But due to requirements, it's a machine age or human and machine age. Today we need data centers. We need hospitals. We need hospitality. We need everything. So the requirement is naturally different. We can't avoid transportation. We can't avoid using of the energy. But how it should be resilient, that we have to have the importance. Today we are talking about the meetings, virtual meetings. Yes, you are in somewhere in the corner of the world, but we are connected. So a lot of energy is saved, but we need to understand the logics behind that. Coming to the structure, which is an integral part of the designing architecture. And when it comes to the synergy of architecture, structure, form, and all the things, because I'm taking word of architecture, because the planning starts basically from the architectural table or architect's mind, and then entire thing follows. So when the architect designs, In fact, I'm being architect and structural engineer and some kind of a multidisciplinary engineering education. I understood that the thing which starts, like a story writing. When you write something and then entire picture follows, and every element, every person in the entire movie making or that particular design or whatever object, I think everybody is important. So here we need to understand each role and then club accordingly. To start with, the projects in which we are involved, and especially since 25 years, I'm involved in the project right from CM to CM. That may be a common man to the chief minister, or very prominent buildings at the same time. Very very simple buildings I do undertake, and I involve as a transdisciplinary conceptual approach. So there are some typical buildings which I have done right from the methodological part, right from the modern buildings, temples, and whatnot. I mean, different kinds of institutions, glass buildings, and with different forms, institutions, and all. So I was fortunate to be involved in these projects since long. There are very few which I wanted to just inform you. And this is one of the heart-touching and my favorite Anchuri family's design, which is in Vijayanagaram near Visakhapatnam. This is a mythological park. About 24 years back, we designed this, and this particular thing is in a arrow and bow shape, where the entire Ramayana is depicted in the form of the three-dimensional sculptures, and in this ground floor and first floor and other different floors, we have Veda Patashalas and Agam Shastra research centers and other things. So it's a very very typical thing. Not only structure, not only architecture, not only building services, but here the Agama Shastra, the involvement of the sthapatis was more. Accordingly we need to have that. If I design a hospital, doctor's input will be there. If I design temple, I need to have Agam Shastra, Sthapatis input. Every element we have to take care. That is what nothing but a transdisciplinary concept. When it comes to the structures, there are several types of structures which may depend on type, which may depend on the structural system, the forms, and in fact, one-dimensional, two-dimensional, three-dimensional structure based on the application. So whether it's a bridge, aqueduct, canals, dams, railways, roads, and airports. Based on the materials, for example, timber, concrete, metal, aluminium, whatnot. Today we have good number of products which can be used. Earlier, about 20, 25 years back, materials were there, but the availability, affordability, and making or production was little less. Like if you see 25 years back, we were having only 4 types of cars, mainly predominantly in India. That may be Maruti, that may be Ambassador, Contessa Classic, and Premier Padmini. But today we have 100 variants in each company, and we have a n number of automobiles. One is electrical, then diesel, and then whatnot. We have different fuels and different manufacturing and different types. So it has grown. And element-wise structures, that may be superstructure, substructure, foundation, roof, and floor, and walls, and shells, and all. So how or which element is going to the part of the structural system as an envelope that we are going to see now. But for anything, for any project, as such, as we have the Mahapanchabhutas in the world, I think planning, designing, execution, operation, and maintenance is very much required for the balanced or design life cycle of that particular project or building. But for that, for any project to be thought, I think feasibility is a starting point of the project. Functionality is the space used for what? Technology, engineering of building, endless options are there. The sustainability, what we are learning from a few decades, is need of the time. Innovation is the design, shape, and construction. But friends, today we are going for beauty, aesthetics. It should look good. But I think correct is beauty, but beauty is not always correct. These are all my common slides in common talk in everything, because it's a basic fundamental things. But structure is not only a structure. There are different, even like inner engineering, what we have. It's my body, I'm a body, I may be fit, but my inner engineering should also be fit. Only aesthetics or only body is not. So it's a, for example, I have a phone, I have a system. Everything hardware is good, but software, we need to that. Software, we have programs, we have well, everything, collectively that can perform well. So today we are going to talk about the structure or the building which performs well, which is the need of the hour. So before going to that, even I wanted to relate the structure and the space. The diagram can be seen. So how the structure and space is related here, and how it can enhance or disrupt the building's function, or maximize the functional flexibility, or articulate the circulation, modulate or introduce the light, organize or subdivide or layer the systems, create a phenomenal effect. So how that can be done, we will see in coming slides. For example, in this particular picture, you can see the structure for enhancement or the disruption of the functions. See, sometimes if you see the Leon School of Architecture looking good, but it disrupts entire the space. And if you see when the structure is effectively used, the structure can help to define the nature of the space. The structure can also disrupt the function of a building wing or built wing, but this is the rarely to deliberation intention of the architecture. So we need to understand the basic function. At the same time, the space is what we are designing, whether it's a column free space or whether it's a height, headroom is also very important. So structure enhancement. So in this particular case, if you see the structure for maximize the functional flexibility. In fact, in the right side, the High-Tex, which is in Hyderabad, the hall number 4 is one of the biggest in the country, where you can host about 10 to 12,000 people under one roof. It's not like a Bharat Mandapam, but it's a multi-purpose use and recently come up. So maximize the amount of interior structure inside a building can be difficult, but for the large one structures today we have technology, so structure should be designed accordingly. Now, structure for articulation of circulation. So this is one of the outlet near Hyderabad airport, which we designed, which is inch by inch. This name is inch by inch because the flooring is now very, very different type of flooring, which cost right from 5 rupees per square feet to 5,000, 10,000 rupees per square feet. So that particular vendor or manufacturer thought instead of mm by mm, it's not mm by mm, but inch by inch is very important because the space is also inch by inch. So here we could have a very long span PV structure with very huge height and all. So the structure, what we design, keeping the inside function into mind. So it's later we will go into outside. The structure for introduction of modulation of light. Friends, you might have seen this particular structure, which is a Bangalore new airport. Based on the bamboos, and you can see the natural ventilation inside. Prime Minister sir, they inaugurated few years back, and this is one of the very, very favorite facility which can be enjoyed thoroughly. Not only the flights, waiting and shopping, but you can feel the difference when you go inside. It's one of the wonderful project as per me in the present time. Now, structure for organization, subdivision, and layering of the spaces. That may be the atrium, that may be the facades, that may be a freestanding row of the columns. So this particular thing has to be integrated accordingly. When it comes to the phenomenal effect, now this particular building is a new department of civil engineering in IIT Hyderabad, which is a steel building, excellent structure, which is exoskeleton because it has a skeleton outside. So this particular steel structure with 2,300 tons of steel used for the construction, and backside it's concrete. The structure designed for protecting each other from the seasonal changes, because the envelope, the envelope like our skin, whether I'm in, I can't wear the same thing in Rajasthan or Kashmir or Kanyakumari or Kolkata or Nagpur. So we need to change our costumes having required U value or R value. So like that, this particular very, very highly rated, green rated building is excellent, not only in terms of the aspects, in terms of the prospect. So structure plays a vital role to bring that. And this particular building is our own T-Hub, which is around 11 stories, 3.5 lakh square feet, which is a incubation center when the mind, which those who are having the enterprising nature, when they come here, just they instigate, or that will be influencing them to do better. So in this particular thing, startups, corporations, and government and academia and investors to drive transformative changes. I mean, so this inner courtyard and these external aspects or prospects definitely attracts, and that gives a different kind of output. So the structure plays a vital role. Is it a new thing? I don't think so. Ornaments in the temple and buildings. If you go to the south or any temple as such, Madurai Meenakshi temple or Surya temple or Mohenjo-daro, Harappa, or Khajuraho, or any structure, when the ornament and structure becomes a single thing, strangely enough, and the result is a new feeling of freedom. And different. You can see the modern, you can see the right from the present 3D and parametric design. And this particular temple we are designing in Devarakonda, which is around 100 kilometers from this place. So we designed number of stupas, number of temple shikharas and all, where we need to study the intrinsic requirements of the. So recently, we are doing one project in Srisailam where that particular thing belongs to some ashram. So they have their own methodology of thinking. They follow some kind of rituals. They follow some kind of ornamentation. So we need to sit with them, and then we have to design and execute accordingly. It's a very wonderful experience, in fact. Friends, coming to any object, for example, when we were kids, today we are going for more of a screen time. But in our times, or even today, we have that exercise. Today we are thinking of national education policy, where we must have some kind of a exposure to the practical thing, and has talked to AICTE, where the first year, second year, third year, they are going into the industry or the field and trying to understand. But when we studied in 80s and 90s, or even before 2000, we had carpentry, smithy, electrical, everything. First year was common for all the branches. All the subjects were compulsory. We went to each of the experimentation and laboratories. So we have different type of that logical thinking. I think that particular virtual thinking is to be improved when you are having a practical logical thing and when you touch those particular objects. So this is what in terms of structure. So before going really into the beyond structures, I think morphology is very important, which is the form and the structure of an object, where anything is account of the form, seeks to the general theory of shaping the power of organic structure. The materiality of architecture has determined the blood relationship between the design and engineering, and there is an instinctive thinking of material gravity and construction, because the load part is very important. So it's a very simple picture, but a very, very, once you dismantle this, then we need to again assemble this. That's what the kids, they grow their even thinking, challenge and capacity, and they exercise, mind exercise. So that's the beauty of even building. Building is also assembly of all the elements, joints, and then each element is different, having different age, different output. So that's what is the collective building, like a machine. Now here, when it comes to the different typologies, I will quickly go to 1001 building forms, very, very at a jet speed, which was the work by Francois. So here you can see on the right side or left side, which is Frank Gehry's project, and right side is a simple box element. If you go through Frank Gehry's works, he takes a sheet and he does like this, and this is predominantly is envelope or the enclosure of the buildings. So you can resemble that particular methodology of generation of the form, what he does it, But then the challenge starts. So his mind, an architect's mind, or that Frank Gehry's, creation. Then real challenge is vertical transportation, horizontal transportation, building services, farm work, everything. Engineer makes that happen. Engineer brings that particular thing happen. So here you can see the farm, different buildings. These are all existing buildings, farms, which somebody has done on here and there on the earth. This is the only collection of those basic forms. That may be a monument, that may be a building, that may be some kind of a structure. So here you can just see how the list goes. So these are all envelopes. These are all enclosures. Somewhere, maybe even Lotus temple, we have Baha'i temple, we have Burj Khalifa, we have Norman Foster's buildings and other things. Just see how so there are sightless 1001 building forms by Francois Banciac. You can just go through his beautiful book, how he has detailed these things. So, friends, if you see, when the proposal comes, so I'm reiterating and emphasizing the role of engineering collaborator here. See, you may be having some idea of mechanization. You may be having some kind of idea of revolving it. So if you take example of David Fisher, architect David Fisher, who is one of the dynamic architect, or James Law, they have different types of products. Particularly David Fisher, his plates are moving. Plate in the sense floors are moving or rotating. So how those are rotating? It's not only the structural engineer, it's not only the mechanical engineer. We need an automobile engineer. We need to control the aerodynamics of that. We need to construct. And also there are about 20-25 agencies which are required. And when I was talking to him, when I got the opportunity to talk to him in one of the places, he said, right from the day one, when I think of something to be putting on the paper, I concept. So, for example, I want to have a speed, wind speed and all. Ferrari people, if something is joints and all, or some fasteners, he speaks to the Bosch experts or wind analysts. So everybody, he takes the clarity and so slowly he forms the particular structure, form, so, which is the envelope. So here you can see one side it's a lawn and play, and the other side, you just imagine when you walk on the carpet somewhere, if you have undulations, that became the project. So this particular team has made such a wonderful, arena, which is, see, because sports facilities and other facilities, they are used by few people, but they are seen by many people. And that will be in the heart of the city when you see that landscape should be merged with the entire landscape. So this was the park and aquatic center. So if you see this particular building, which is HA Tower, which is located in the Tokyo, here you can see the collaborators have come up with the concept, which is the progressive stretching of a spacing height results and in a building type that symbolically escape its own location. So here they have played the differences in the height of the each floor, and they have come up with, and you can see how that particular building, even though it's in a congested place, you can see how that was looking there. So here, another beautiful project, Taipei Performing Arts Center, which is located in Taipei, Taiwan. This particular cultural reference of Taiwan is the Aboriginal construction technique using the slab stone heaps. And the project similarly piles up the 4 slab stones, 3 theaters, and 1 which is containing the administrative office. So here it helps the stone pile up as a memorial or as a landmark also. See, some kind of some people, they go for flower of the nation, but even in Hyderabad we have rocks. So in this particular area, these kind of monuments are more. So the idea behind the development of this is like this. So for example, how structurally they kept it and how the overhang. So inside the structural system and outside for example, other day I was talking to Abhayji, who is the expert in the statues, for him there is no choice. There is no, say, if you want Sardar Patel standing position, he has to take that position, and entire he has to do analysis. He can't change even one wrinkle on the face or any shape or size or proportion of the human body, because it's a true scale. It's like a portrait. So his challenge is something different. So he has some different challenges here. You can go through his works, and they're very, very, no, his company's name itself is Skeleton, because the skeleton and the envelope. So I'm today talking about the envelope, but we have to integrate that. So here, if you see the theater, you can just, slicing down the some kind of fruit, and just like a series of cuts of the original spherical volume, and tilted to allow the pedestrians to cross freely through the public spaces upon which the building sits. So they can move through the building. It's an entirely different concept, and come up very well. So you can just see how the ball started, and the spear, then they cut, and then based on the orientation, they have angled, and then the generation of the form happened. So here we have another important 23 spears came together, they interlocked, and they dissected or bisected within, and they came up with this particular beautiful project. For example, this Lima Towers, 16 apartment units, which were in a series of blocks, and which undulates along across this particular spinal central, and then if you see earlier building, they were parallel, but here it's like a spine, and then angular differences. You can see how the different they have done it, because the structural system is same, but the envelope, outer shell, they have designed accordingly to have the illusion, at the same time the aesthetic view. So coming to what engineers built yesterday, we have seen right from the temples to the present day, but here you can see the opaque structural era. We had different eras. For decades, we mastered the structures. Yes, I'm not having any doubt about the structures. So, in terms of earthquake resistant, in terms of wind resistant or the disaster resistance building, advanced in the structural analysis and design and execution. But considering the legacy of the projects, the robust concrete frames or solid brick in fields or raw structures, we calculated safety with outstanding precision. No doubt about that. However, this absolute focus left building dynamics or building thermodynamics. We forgot about building physics, and then creating massive energy guzzling structures that rely on HVAC, brute force, to remain occupable. We have come from unconditioned spaces to the conditioned spaces. Everything is air conditioned. See, whether it's, say, for machines, yes. 25 years back, we used to have a 386 PC, which required dust-free atmosphere, like an operation theater. We used to put our chappals outside, air conditioner or controlled temperature was there. But today we have highest version computer, which resists everything. In fact, there is a gadget in our hand. So what I mean to say is that particular system came and gone, but it has made us right from the schools, they are air conditioned, toilets, they are air conditioned. When you are going in the bus, that is air conditioned. So everything is conditioned. So condition apply means gone. So I think nature has no condition at all. In forest, I think no pesticide, no watering, it grows on its own, and it's a nature. So why we can't have our own building or system, which is nature-based? So I think we need to have less of active, more of a passive. There, the engineer's role is more. So what engineers must build tomorrow? I think active environmental systems. The tomorrow's engineering begins where the structural design ends. So once your successful design ends, or engineering design ends, I think we need to think of a sustainable thing. So tomorrow's objective is a carbon negative performance. I think we must know what is embodied energy, what is the strain energy. I think as an building services engineer, you can reduce the consumption of the energy in the operation. But as a civil and structural and mechanical and electrical designer, you can reduce the energy while construction itself. Because the form, the shape, the material, what is used is also consuming a lot of energy. So for me, I think if you reduce the strain energy, I think you are achieving the good carbon footprints. So here we need to harness the natural daylight, breathe during the pleasant ambient hours, and maintain indoor thermal stability even during full power outages. I designed number of buildings, and even where I'm sitting, my own small 8,000 SFT multi-floor house is a purely energy plus design. I mean, I generate my own power. I have good daylight and other things. So there is no air conditioning, or hardly I use any air conditioner in a year. So we need to understand that. So who are the victims or who are the contributors? I think buildings are both victims and contributors to the climate change. We are trapped in a feedback loop. Rising temperature drive greater AC uses, and which expels more waste heat and burns more carbon, further raising temperature. In fact, the only escape is to reduce the mechanical heating, cooling loads, and at the source itself. And the envelope should be accordingly designed. So our future climate is already arriving. We need to understand the Indian heat wave is a reality. In fact, you see the temperatures of the cities. If you take the Delhi, it goes around 47 degrees, and Nagpur 50 degrees. And most of the cities which are not even experiencing 30, 35 degrees today, even though 30, 35, 35 degrees, the humidity level or the heat, the climate is different. So we need to understand how and what is the man-made interventions and how we are spoiling. The future of the climate is already arriving. We need to be very careful, at least for the upcoming built environment, and you can correct the existing buildings also. So cities are becoming a heat trap. The standard concrete and asphalt absorb solar radiation during the day and continuously radiate it back. Our buildings must be engineered with reflective, low mass surface materials to break this destructive cycle. I think we need to understand the urban heat island mechanism and then go for the design collectively. So resilience is the new safety. We had fire safety, we had earthquake safety, so all types of safeties we need to design. So suddenly our zone 2 becomes 3, 3 becomes 4. But what about the existing buildings? So we need to design the buildings considering the future in mind, leave out the present. So based on the past, we have to design the present, considering the future. That's what the future ready building is. So resilience is the new structural safety. The traditional structural safety focus ended once the building stood firm. But today, we must guarantee complete water tightness, complete structural envelope integrity during severe storm. Other day we had very, very extreme calamity in Visakhapatnam. Almost 75% of the public structure, including airport, it was lifted to 1-2 kilometers. So what is that? So we need to understand, and we have to change ourselves to the performance-based design. Fortunately, we have the new NBC, which is called as National Building Construction Standards 2026, which is performance-based. Definitely, we need to come together, think seriously, and make this thing. And that there is a special chapter for the sustainability where ECBC and other things are incorporated. Friends, envelope is a building interface, which is the roof or opaque walls are, I always say, when dot transfers or dot travels, it becomes a line. Line travels, it becomes a plane. When plane travels, it becomes a solid. But earlier, our structures were solid. That may be pyramid, that may be any kind of a monument. They were not hollow, they were solid. But today, we are thinking, say, for example, pyramid was solid, but today's pyramid is hollow. So today, the requirement is different. The function is different. So we need to understand the complexity of the geometry of the structure, the flow of the systems, and then we have to go with the interface. So envelope or looks is same, but inside it's hollow. So thinking of the envelope as a continuous wrapping, any break or poor transition between the roof, walls, and glass will compromise the entire building's energy performance. You should think as a body, human body. The other day I was talking about the anatomy. So even if my one finger pains, my entire body is going to be disturbed. So we need to understand each element of the building and then go about that. That's what I was comparing the human body and the envelope, where we have the thermoregulations, airflow, moisture management. The buildings breathe, gain heat, lose energy, and just like humans. In fact, the other day I was part of this Guinness Book of World Record by Saurabh, the yoga about 21 days. Believe it or not, 1.5 crores people joined. I think that is less because we should go for IPL, 50, 60 crores people join for, I don't say nothing, but I think we need to think of our own body also. We do Kapalabhati, we do breathing exercise, but our building where we live, are we going to give the required fenestration, required air change? If a toilet needs more air change, kitchen requires more air change. No one thinks of that. So we need to understand each body or each element in the office or any space, and we need to accordingly design. So that is what the I was comparing with the human body and the animal. Now, thermal imaging analysis. Today we have everything. Earlier we may be little not available, but today we can simulate it. We have design builder or so many good softwares where we can simulate. Before even going for the final design, right from the design, like we are analyzing our structure, we can analyzing our structure as a whole also, as a body, as an envelope. So where we can put the fenestration, where we can put the openings, so energy leaks and are often invisible until it measures. So we need to have some kind of scanners or systems where we can even check the strength of the concrete, check the strength of the beam element. At the same time, we can study the performance of that room, that performance of that entire structure. So that is what we need to go for. So physics, yes. So building physics is a very, very important subject. Laws of the physics are very important. We must know what is conduction. We must understand what is convection. We have to really seriously think of the radiation. So pure heat movement through solid walls is a conduction. Convection, the air, hot air drafts circulating through envelope joints, and radiation, direct solar heat transmission through the glass. I think we studied this in the third or fourth standard. So every watt entering in a building follows the law of the physics. So we must engineer the distinct defenses against each mode of the heat transfer. That may be low conductive materials for the conduction, airtight seals for the convection, and shading devices for the low E devices or the low E glass radiation. Friends, I don't know about the north or some part where still I don't know whether the ventilators are being used, but we used to have ventilator above our window where the hot air was going out. We used to have Venturi effect in house. We used to have stack effect in house. Entire thing gone. Construction, we are just construction boxes. We are putting some fenestration irrespective of the lighting required direction, orientation, and we are packing it. And then we are putting air conditioner. Whether it's having see, that's what the post-pandemic, the living buildings are very less. Earlier it was not. But what I feel is we need to have healthy buildings. We need to understand what is R value, what is conduction, what is U value. I can't have the same U value for Kashmir and Kanyakumari in terms of my clothing. Like that, we need to have food, shelter, and clothing accordingly. Now, the cost of uncontrolled solar gains. So, peak overheat solar demands. The sun is free, but uncontrolled solar gain is also expensive. We can see you can't have haphazardly plan anything. So we need to understand. We need to calculate how much sun is required, how much energy we can produce, and how the roofing system can be done, and how the AC loads can be reduced. What kind of a system we can use it. So visualizing the invisible load. So these things are not visible. So managing long wave infrared energy is very important. So what we cannot see often drives the energy consumption. So sometimes leakages, we don't know the leakage. It's not only the water leakage. We need to have controlled, what to say, we need to control the leakages. We should not have any leakage in the room, or especially in terms of the usage when you are designing some kind of a machine type things, data centers or operation theaters and all. So standard glass allows the near infrared heat waves to pass freely. The energy heats interior carpets and also heat increase to the glass. So properly glass. See, for example, I can have the for my eyes require the glass of different number. Optical glass is different. So I need to see properly. Like that, when you are putting some kind of a glass, whether it's a south facing, north facing, whether it's west facing, how the heat increases. Accordingly, you need to plan the value of that particular glass. So otherwise, it will be difficult. So ASHRAE, which is the association for controlling this air conditioning and other things, it's a very, very important charge they have given. The comfort levels, how we can achieve through those, so that may be relative air temperature, that may be relative humidity, that may be air velocity. So buildings are for the people. If designed, we have to design for the machine. But predominantly our buildings are designed for the human comfort. If for human comfort you achieve, then naturally the machine comfort will be there. As I was saying earlier, computer, now computer, they are different. So today we are designing the computers or machines for that particular temperature or electrical loads. So we need to understand. So occupant comfort and productivity is related. So create the spaces with productive mind. You need to have biophilic design. You need to have the nature-friendly design. So whether it's a classroom, whether it's an operation theater, whether it's a hotel, if entire thing is going to be same in terms of say when you close your eyes, your ambience can be felt. If you are opening the eyes, that's only a excited things. But I feel when you are closing your eyes, when your other senses are feeling the atmosphere, I think that is required. If you go to a puja room, you know that it's going to be a puja room. When you are going to a hospital, you should not stink or you should not understand. So some places it's required, some places it's not required. A comfortable building is a productive building, and here the envelope plays a vital role. The climates, like earthquake zones, we have climate zones in the country that may be hot, dry, that may be warm, humid, that composite. So climate should dictate the design. So accordingly, design should not never can dictate the climate, isn't it? So the heritage architectural lessons, yes. When you go to the Rajasthan or Gujarat or some places where Havelis are there or where palaces are there was no power. The building material, the structural systems, the all other materials and the plannings, entire thing was accordingly. No conditioner was there, and still you enjoy that space. That may be stack effect, that may be windmills. Right from the water supply, drainage system, rainwater harvesting, everything can be learned from the past. And we are just our generation or new generation, the Gen Z. I think we need to be little, going to the Haveli and taking the selfie and coming back is not. We need to have some kind of a more perception for seeing it. So our ancestors practiced sustainability before it became fashionable. Today, more than a passion, we have a passion. So we need to understand that. See the Jaipur courtyard and Jali screens. If you stand there, you will get a breeze. For example, Venturi effect. When you get a cool air. When you blow out, hot. When you take the air in, it's a cool. So we need to understand that particular flow off and aperture. So passive cooling is a timeless engineering. In fact, passive is always active. Active is active when the power is there. Very simple thing. Even in case of fire, you need to have passive things like a staircase or fire exits or in terms of the fire rating and all. They are all passive. They are always active. But active sprinkler systems and some kind of a mechanical system, if they don't work, gone. So passive is more important, and active can in fact enhance their particular working. No doubt they are required, but we need to understand. For example, if I have a rectangular building and north and south, whether my building should be like this or whether my building should be like this is very important, because the moment you design your building north and south and keep opening more on the east and west, naturally heat increase is going to be more. So while unavoidable, then you need to design the shading device accordingly. How it can be? You can see the solar sun path optimization. We can optimize based on the landscape, overhang, then horizontal lowers or the vertical lowers. So the best energy is the energy we never consume, isn't it? So that should be the practice. Today we forgot all these things. Today you see there is no sajja for the window. I think high performance shading, you can have different. what we do, outside we put nothing, inside we put blinds. You can see even behind me, but we have this good shading device. So it's a part of structure. So here, horizontal overhang geometries are very important. If you see Golconda in Pondicherry is the product the Nizams about 100 years back they funded and did it a wonderful project. Exposed concrete structure and completely it's a passive design. So we can really work out without anything, and that structure can itself is an envelope. So vertical fins optimization. You can have horizontal fins, you can have vertical fins. So designing the sun instead of fighting against it, we need to understand and design our fenestrations and shading device accordingly. Now, wind and CFD analysis is very important. Now, computational fluid dynamics. Now the tools are available. Today we can easily simulate it. So why don't you use those things and try to, even there is an app which even you can put the location, you can put the building form, you will get the CFD analysis and then you design your them. So wind is a renewable resource too. We need to accordingly simulate and use it. Now AAC block, definitely, and where the red burn there we have porotherm and other things. But AAC block.
Devpal Singh, can you please go on mute?
Anyway, I'm trying to talk more louder than him, but anyway, so AAC block versus the red clay brick. Now, when you compare AAC brick with the red clay brick, now AAC has a very less U value, very high R value. So I think when you replace a brick by AAC, because your building is going to be structurally sound because of the beams, columns, and so structural system is there, then these walls are going to be only partition walls or the external walls with shaded. If you have the shading for the external walls, you can definitely go for the such kind of system, which will reduce the energy by 30 to 40%. So insulation wall is, see, today we are talking about the 50, 60 stories building where the concrete shear wall is must. Now concrete wall, definitely it is going to heat up and its U value is too high. So which is not recommended, but the structural system is required. We are going to have an envelope of concrete, then how to go about it? Either luckily, if you have a core wall, then and a hollow core external walls, to some extent it can, but if you have insulation from outside, then say for example, if I am going to Kashmir, I will be having Twitter, which is having good R value. So insulation is very important. Thermal bridging is very important. Heat finds the weakest part. We need to understand. So these visualization conducting. So there are some kind of machines or scanners available. We can dampness we can check. At the same time, leakages we can change. So definitely we can check the things. Here glass inspires the architecture. So here you can see the glass inspired architecture, but challenging the engineering also. So we need to have proper SHGH values and properly designed DGs and all. Definitely glass box is not bad, but we need to design accordingly. So single or double glazing. In fact, we go for triple glazing also for southern walls, western walls. For north wall, you can go for single glazing, but for western and southern, so that depends on the heat ingress. You can check it and accordingly plan it. Now, low E coating technology is also very important. The glass which is coated with the low E coating reflects the heat. The light will come, but heat will not come. So I have a lot of skylights in my projects in my even house. So where I can get the light, but that reflects the heat. So that we can plan it out. So optimizing glazing performance is very important. The right glass reduces the cooling loads before HVAC starts. So we need to understand how much should be my SHGC value and all. So daylight harvesting is very important. You can see in earlier courtyard houses or villages, they don't require any lighting, daylight. Even the design, special design, and from Suryodaya to Suryast. Why you need light inside when you can take the light from the nature? So you take the light from the nature, from Suryodaya to Suryast, generate the power, store that, and rest of the area, Suryasta to Suryodaya, you can utilize it. I think I'm not even paying any bill to the government since 12 years because my building is a net zero building. So in fact, I'm saving and I'm storing that in case of, because they don't pay back, but at least they neutralize it. The danger of overglazing. It doesn't mean that you go on putting the light, glasses and all. Where to put the glass? See, this is the another irony of our, mindset is that they have seen something in Japan. Oh, same thing we are putting here. It's not. So we need to see yoga is always better than aerobics. No doubt about that. So here, local things we have to see. We have to have combination. How much should be the glass? How much should be the wall? What type of a percentage of glass we have to use? How much opening penetration? It's a good science. So this is what window to wall ratio. This is very much seriously given in NBCS 2026, and it's a part of National Bureau of Energy Efficiency ECSBC, Energy Conservation and Sustainability Building Code, and we are practicing that very seriously in Andhra Pradesh and Telangana because it's a mandatory. So, what is windows to wall ratio? How much is the wall? Which side is the wall? How much thickness is the wall? How much percentage of the opening is required? Are we going to do it? I think we need to do it because this is a structural system which is going to be external facade. How much opening you are putting, whether it's a shear wall, whether it's a partition wall, whether it's a load bearing wall. I think we need to understand where to put, how to put, and what I to put. Then optimize, which beats the maximization. So here, as per me, the envelope is maximum. The roof also, isn't it? So terrace or open to sky, which directly undertakes, we have ingress. Naturally, in a multi-story building, only top floor is having the ceiling, but there, Telangana government and it has come up with the cool roof policy, and other governments also, they are planning. The roof receives the building's highest solar punishment. So we need to understand. So what we are doing false ceiling. We are putting some glass wool inside, but what we are not treating the roof. Upper floors, they are having the false ceiling. Putting the banyan inside won't give me much, in case of raincoat, I can't wear raincoat inside. I have to put the raincoat outside. Like that, we need to wrap something which gives the seat or ingress in terms of the building enclosure. So when I'm saying enclosure, that structural system should be accordingly. So cool roof technology, here we had this Telangana cool roof policy, where I was one of the instrumental in the policy making and even implementation. So every building which is more than 2,000 square meters must have this cool roof coating on the top. But again, it's not only total cool roof. We need to have power roof. We need to have green roof. We need to have normal roof. So everything which reduces the consumption of the energy inside is welcome. So reflect the sunlight, reject the heat is the purpose of the main roofing system. So here I was saying about the green roof. Wherever it's possible, you can have a living green roofs, which gives a substantial reduction in the reduction in the energy, because nature can be of a building material. And here you can see, when I say enclosure or envelope, the Dakkan, it's not only this, we need to have, and in some buildings there is no wall at all, entirely roof. I will show that. So here the hydration and the blue roof. So blue roofs also can save. So future roofs will manage both heat and water. So here, if you see the solar roof integration. So if you are planning some kind of a pergolas on the top, why don't you go for a hybrid? I know today we are getting a transparent solar panels, which you can see from the bottom, you can see the sky. So such developments are there. We need to update ourselves. We need to use it accordingly. Every roof is a potential power plant. Now, one of the best example as per me is a AI Bahar towers, which is the, you can see the glass, and it whenever based on the, and it tracks the sun, and based on the requirement, the openings and closing, the building that responds to the sun. So it's a climate responsive facade. So that is the need of the hour. So kinetic facade, you can just see, we have a full glass in the night or evening, and then as per the requirement, the building gets closed. So like shading, like it tracks the heat and light, and then accordingly this system, it's called as a kinetic facade. Now, when it comes to the active glass, there are some glass. So you may be having this shades which photo gray or something that is called. So that becomes gray or dark when you go to the sun, and when it comes inside, it's a clear. So based on the requirement, that glass can also give the particular ingress of the light and heat. So double skin facades is a new thing. If you are pointing HPL, that is high pressure laminate, ACP, aluminum composite panel, or some kind of additional cladding. We have an original structure, then you have some kind of a gap, and go for a next skin. That is double skin facades, which is a very, so this particular facades are designed structurally safe, because you have a tall building where the wind, and even if you see 16700, which is the code for the tall buildings, it has been very clearly said that which are the structural elements, which are the non-structural elements. So how to design that? So here BIPV facades, which is building integrated photovoltaic facades. Today we can have a glass which can even generate the power, you can give the shade, and acts multi-purpose. This is the need of the hour, and soon it will be very, very comfortably used because it's going to be very affordable in coming days. So high wind and cyclone defense, the structure should be designed either in terms of the form and geometry to resist the wind, or the materials itself. So if you don't have any choice to design with the shape and size, then your design should be accordingly. So climate resilience begins at the envelope stage only. So entire safety of inside depends on the outside. So one very young, I had some small competition. So here the flood resistant envelopes. So the young mind thinks out of the box. They always have some kind of a different, adaptability or something. So adoption is the new sustainability. The flood proofing lower floors is essential for the urban resilience. Using temporary water gates or impermeable barriers helps keep critical systems safe and dry. Because today we are going 2 basements, 3 basement inside for the parking. At the same time, we are going for the lawns and upper floors and with different challenging things. So we need to understand. So fire safe material selection is very important. Today we are every alternative we are hearing about the hospitality accident, school building, industry, even moving bus also getting fire, EV vehicles fire. So it's a very, very, very. So we recently even launched one council for fire and life safety professionals, and coming up the unified code. So envelope failure should become life safety failure. So one is life safety and it is property safety. Everything depends on the design. So adapting to future risks. So we need to anticipate the future risks and design the future ready envelopes. So when I say envelopes, it's not having any limit, whether it's a 2050 or 2070, but right from now, why don't you design resilient or future ready buildings? So healthy buildings and healthy minds. If my building is healthy, my mind is healthy. Health is wealth, isn't it? But wealth is okay, but health comes where? When you are staying. See, post-pandemic, we are spending about 95% of our this time inside. Now, you know how the atmosphere is in Delhi, how is Chennai and Hyderabad. So some areas are good, some areas very bad, some areas are improving. So healthy buildings create healthy people. So when healthy people are there, then productivity will be more. That is what our young India requires. So air tightness and indoor air quality, definitely it's a very much. And one more challenge is you are very nearer to the chemical industry or industrial area. You are very nearer to the coastal. So how my building envelope should be, we need to understand. We need to utilize the apertures and penetration accordingly to keep the indoor atmosphere safe. So air quality is the next frontier of the building performance. So coming to the daylighting and circadian rhythms, if you are in a daylight, if you are in a nature, nearer to the nature, your body will be active. You will. Are you going to perform your activity or yoga in a very clumsy area? No, you will be going for where the ventilation. So it's not only for that thing, but throughout you should have that. 24/7 you can plan. So natural light improves the human well-being. So natural light access, reduction in eye strains, and better sleep. If you work good, have good health, then sleep is also good. So BIM envelope integration. I'm coming very closer to my presentations. So here building information modeling. So if I am using that particular BIM modeling, if my other counterpart or associate is not using, then it's a problem. Still in India, we are not on the same page. We are on the page of thinking, but we are not competently using all those systems, because we need to understand. So if today we are talking about the future ready buildings, I will just go through how the future ready buildings are there. So digital design creates the predictable performance. So BIM is very important. Dynamic energy simulation can be helpful, because if you can't simulate, you can't optimize it, isn't it? Naturally, we have to simulate, we have to regenerative architecture is okay, but generative structural or engineering design is very important. So here you can do that. So continuous performance monitoring. बांध दिया छोड़ दिया ऐसा नहीं होना चाहिए हमें. We need to see, it's like a vehicle, when you are not operating properly, when you are not maintaining properly, how it can be, वो start ही नहीं होगा. So ऐसे ही हमें building, we take care building, we ignore the things in the building, we hardly any paint, we hardly maintain. So I think we need to understand the entire so see, and the building envelope is saving from outdoor, indoor, outdoor, or everything. And we are not caring about that. So we need to understand the importance of the structural system of the envelope and take care of that, so that we can monitor and perform well. So AI-driven facade controls are the new in the market. We are using in one of the hospital, which is very, very modern hospital, where artificial intelligence is becoming the engineering partner. They are going. See, we are having a digital screens which displays outside. So at the same time, some kind of facade systems which are controlled by AI. So naturally, what is AI? It's just also a tool which is programmed and it's artificial. Nothing big about that, but we need to integrate that. That's very important. So ECBC envelope requirements. So when I say envelope, we have requirement that may be maximum roof heat transfer, maximum wall heat transfer, maximum glazing transfer. When I think of glazing, I need to know the value of glass. When I talk about the wall, I need to know the U value. When I talk about the heat from the roof, so entire envelope, I need to understand the building or its physics. Now, this is one of the India's first building, which was a platinum rated building. I'm a part of this IGBC as a core committee member, which is today it's a net zero plus building. And you can see how this building is demonstrated. If you visit Hyderabad, especially you visit this particular building, because we have all the data, we have all the required library and display of materials and everything there, which can support you to come up with the sustainable and future-ready buildings. You can take another government building-based building. This is the Indira Paryavaran Bhavan, environmental based only. So it's a net zero, which is having a shade on the top. It's like an umbrella on the entire building, which gives the shade. Instead of individual shades, they have planned total big umbrella on the top. And in Hyderabad Infosys building, you can see not many alternatives. They have used the radiant cooling system. They have used the facade, which is giving the shade, which they use the material, which is having a good required U value. So Infosys is one of the example which is very good in the envelope design. Now here, Snoheta designs. So if you see the external, I mean, some international projects where here the jali, the terrace and planting are meant to introduce the permeability and calm to the terrains. You can just see how the mesh is provided. The vision is clear and mesh. It's like a jali, we are thinking about jali. And brickwork, Delhi and Chandigarh, we have a lot of terracotta. So you can have apertures in the terracotta. You can use those things. So hole in this brick gives a semi-transparent character to the solid block. Instead of going for solid, they have made the structure in such a way that the air will come, light will come, but heat will not come. That's the beauty of this particular project. So here you can see the roof itself is coming down. So this entire roof is becoming an envelope, and that is enclosing. So we have pyramids and domes earlier. So today we have this. So why don't you have the sense of movement blending into the landscape of urban? So today we are thinking of having a integrated design with the urban planner. So we can think of this, which gives ambient ambience also. Yes, construction technology. This is the one of the best 3D printed building. It's a two-storied building. It's not like a three. If you see the 3D printed house, immediately we can identify it. But in this case, it's not so seen because it's a little advanced technology. All the people they have come together, and it's one of the best kind of structure. So we can go for affordable housing with 3D printing, which is having a very good enclosure as a structure. So here you can see the building which has a glass, but it's not only a glass. It has a shading device. It has even photovoltaic panels. And this is nothing. This particular building is for the people those who are manufacturing world's largest photovoltaic. So they are remodeling their headquarters and they are using those entire facade system according. So you can intervene. You can improve the existing buildings too. Coming to this Raman Ranayanam, which is designed by us long back. Here you can see how the 24/7 that lighting, and in case of there is a very big statue on the back. It's an entirely modern structure with traditional theme, and would love to visit that particular place. So it's a it's a concrete structure. We couldn't do it in a stone, but it's a concrete structure. But we have given a very good shading device and all. It's a very sustainable building. So coming to one of the last case study of mine, which is Sahi, we called as Society for Society to Aid the Hearing Impaired. So for infants, those who are not able to hear in their first 1 month, they are tested here. This is the Switzerland-based firm which has ventured in Visakhapatnam with the help of Andhra Pradesh government, and I was instrumental to conceptualize this particular thing. Here you can see the need of that particular service for the poor people. There is no financial things involved. Any poor or rich can come there, get their infant tested, and then we go for the treatment outside. It's a research testing center. So here I have used the golden ratio, which is seen in everything, right? With the shank and even your face and pyramid. So I could take that because convincing the doctor's team was little challenging, but I used this Fibonacci sequence, which is 0 + 1, 1 + 1, 2, 2 + 1, 3, and 3 + 2 + 3, 5, and goes on. So this shape I developed, and I explained the doctors the human embryonic development, how the conceiving first 1 week to 38 week, how the baby comes, and how our ear or how our anatomy, basilar membrane shape, and then I convinced them to come up with this particular shape of the building. And we have almost about the finished building. And even though this is very nearer to the coastal in Visakhapatnam, the way that air flows, that gets cool and come inside. So I'm using hardly any active system inside. It's going to be because the machine centering, we need to have air conditioner, but the consumption of air will be, so cooling the cool, heating the hot is actually easier, So in fact, we simulated with pins, without pins, with so many alternatives, and we achieved the 6-star rating compliance at the design stage itself. So we achieved this, and this is the first of its kind in the country. And I'm happy to be the first third-party assessor appointed by Bureau of Energy Efficiency to assess the rating systems. Thus, today we have number of people, but we began that, and this is the first of its kind. So the Sahi Vizag, the regenerative architecture with a generative structure. Friend, this is my own small house, the central courtyard, where I studied the sun path and the load path. It's the elevator. So architects, they understand the sun path, but all engineers, they must understand the load path. Electrical engineers should understand the electrical load, lighting load, and then structural engineer or civil engineer, they must understand the gravity load or lateral load, the loading system. The load path is fire engineers, fire load. So all kinds of the loads we need to understand, including the sun path. So here I wanted to emphasize you that let us orient or study the sun path and the load path. So sun and load, definitely our building will be the structure which is very sustainable, future ready. And this is not a new. In बचपन में हम लोग तो खेलते थे इसको. And then now today, due to the digital world, people are the kids are playing games on the screen. But we used to have these competitions. So adaptive build forms. So we were used to enjoy these things, isn't it? The stability and all. Friends, here every element or every stone is a weak. But when it comes in a form of arch, this is the strongest structural system as far as the structural engineering concerned. So even ECI is in the form of arch. But each body or each element, I say electrical engineer, mechanical engineer, civil engineering, there are a number of streams. But if you come together, that's why Mr. Swaroop and all other people are, Mr. BR and all ECI bodies trying to bring us together. Let us come together and form an arch frame or arch structure which will be stronger. So individually we may be weak, but when you come together in this form, it will be the toughest. It will be having all kind of resistance that is inspired by the nature. With this, if I think of form follows function is on one side, but today form follows human behavior. Form follows performance, which is the new normal. So adopt to build forms or a transdisciplinary approach to smart materials and life cycle performance. So design, material, and performance. That brings us to the sustainable and sound structural system, which is little beyond the structure. We need to think beyond the structure. So beyond the structures, what should be the ECI vision? What is ECI vision? I think our new engineering mission, our role has evolved. We are no longer just structural engineers ensuring building safety. We are environmental stewards engineering smart, sustainable, and resilient spaces. Designing for the people first, protecting our climate spikes, targeting the net zero standards. The buildings we can design today will shape our climates for the generation. Friends and colleagues at ECI, our mission is clear. Designing buildings that merely stand is no longer enough. We must engineer the high performance, climate responsive envelopes that protect the resources, support comfort. Let us come together to build a cleaner, and more resilient future for everybody. And let's build the nation accordingly. I thank you, everybody. In fact, this is one of the proposal of ours in Amaravati area, which is the new popular one, which is the one typical building in the cluster. And here, the inspiration was taken by the elements which in coming together as stones or arch. And then we transformed that. Here we spoke to a number of experts in the field, more than 15, 16 experts. And we have come up with this. The only thing is here we are all having the stationary plates. It's not moving because of the local conditions and requirement. We couldn't go for the moving things. But this is what it can bring it with the when you think beyond structures and which is resilient and future ready. Thanks a lot. Over to Mr. Yogaras.
Excellent presentation, sir, and very informative. Thank you so much.
Thank you, sir, for your very informative and fruitful presentation.
Future drive and presentation. Future drive.
Future drive presentation.
Thank you. Any questions? I will try to give answers.
Any questions?
Sir, in case of industrial building, how we take care of this?
Yeah, in fact, very good question. In fact, I wanted to present one case study for the logistic hub which we designed or under design. It's a very, very, very different. I think I will just try to show it. Just a minute. I do a lot of physical models, in fact. So this particular thing, are you able to see it? So here it's a logistics which we can't see this as a shed or something. It's a very differently designed using the what I was saying transdisciplinary concept. logistics hubs or industrial sheds are not. See, we designed not many, to say, convention centers and all, but here you can see how the shape of the building, how the formation of the layout and everything. You would love to, even in fact, the logistics, it's a logistic area. They love to come. They wanted to put their material inside because it's a different shape. That generates the light, heat, and other things accordingly. It's a net zero logistic building which is coming up. So huge area, but the form is different. So even when I spoke to these all manufacturers of the PEB, initially they were little hesitant, but when I told them the optimization of the structures, the same material, the same quantity of material, but little complexity or challenge in the design, I think it can be done. And today, with the advent of mechanization, I think pre-engineered buildings, so it's only assembly. So instead of, and in fact, I love parametric design because the human body is not like tubes and all. No, we have a variation of the section because of the optimization. So I think because of the manufacturing process, I can have a variation in the beams. We studied only column, beam, slab with the regular sections. But if you have the knowledge of joints, and if you take the help of the joint designers, like those who are experts like Hilti and Bose, so they will support us. Their team will support us how to design the joints and how to design the elements. So I think one of the best it's going to be pre-engineered buildings soon and 3D printing for the low-rise buildings. But we are adopting such things in our if you go for Jaha Adit's forms, so these are all optimized one.
Okay.
Anything else?
Sir, the small request.
Yes, sir.
Can we get this presentation? Actually,
Yes,
I am
sir.
driving and listening also.
Okay. So what I will do, sir, I will make a PDF of this and I will send it to Mr. Yogaraj, so he can in turn put on the network and all.
Thank you very much, sir. And it is always nice to hear a very passionate and knowledgeable person. It enriches all. Thank you.
Thank you. Namaste, Goshi. Ghosh sir. You are on mute. Thank you.
Thank you so much. Thank you.
Excellent presentation.
Thank you, Mr. Ghosh.
Excellent presentation.
Thank you. So there is a nature behind you, and your photograph shows the flow of water through the rocks, how the rock forms, how the rock changes. So excellent. You have a very beautiful picture on the back. I will take inspiration and I will try to come up with some kind of a new form.
Yes.
Yeah.
Absolutely right.
Right.
A very good afternoon, Mr. Anchuri.
Yeah, good afternoon.
So I was also looking at many of the sustainable buildings, right from Laurie Baker or Nari Gandhi. Very excellent examples of those times. But what today we are finding hard to live in such buildings is the insect ecosystem, like mosquitoes. So the glass becomes essential even in the remote places, whether it be a village or a forest or remote. So the glass becomes essential. So how do we really think of living in opening a window in such? I mean, what can be done? Can we also incorporate? See, I have also texted you this in the message to better frame it.
Yeah. I'll just go through it. But sir, basically the glass requirement is for aesthetics, isn't it? Now, sometimes it's aesthetics, sometimes. So if your building is oriented accordingly, so for example, if I'm having a north and south lens, so for example, if you have a north, then even if you put a biggest glass, there is no heat ingress because the north sun is not going to come in majority of the regions. So that depends on the sun. So that is what we have to study the sun path and try to put the windows and the openings in such a way that the heat ingress will not be. Otherwise, you put a shading device. So if you have a shade, for example, हम लोग cap पहनते हैं. अगर जरूरत पड़े तो cap, see, it's not only one type of cap. There are several types of caps. I think always I say, go to the tourist place, buy a hat from there because that particular hat is designed for that particular reason. So they may be a sweater or maybe the clothing. So that's what clothing, shelter, and food. You must understand the vulnerability of that. And what we are doing, sir, we are bringing some outside countries elevation and putting here. So we need to customize it. And most of the rest, what we are doing, even if I am having a glass outside, inside, wherever it's not required, we are making it opaque. We are constructing a wall or some kind of a panel. And outside, if you want a glass facade, put it. But if you want opening, I think we need to keep it accordingly. Otherwise, you can make it a single glazing, double glazing, or heat ingress or low E coatings. Sir, if you know our cars earlier, our cars were having a coating or film where our गाड़ी अपने को 20 किलोमीटर पर लीटर आता था. अभी तो वो व्हाइट कंपलसरी हो गया तो 12-13 किलोमीटर ही आ रहा है क्योंकि हीट इंग्रेस बिकॉज ऑफ द सिक्योरिटी रीजन they removed our film, isn't it? So we need to understand what for you are making it, and then we can. It's a little challenging thing, but we have to work on that. But we can achieve it.
So let me conclude my reception. So you mean that we are living with the glass forever, and that there's no escape from all this.
Yeah.
So my question was how to avoid the complete glass.
Okay. Yeah, I got a point. Not only light point of view, but in case of fire, the fire is not killing us, the smoke is killing. So we need to make compulsory the openable things. So today we are going for a, see, basically I have seen why these people are going for a fixed facade. It's the cheapest. If you are having a openable or tracked system, it costs double. So today, if you are going thinking of only fixed, see, wherever you have seen these accidents and humidity or the indoor temperature very bad, it's due to the glass enclosure. Sir, simple. दीवार और फिक्स ग्लास, देयर इज नो डिफरेंस. दीवार दिखता नहीं है, ग्लास में दिखता है. लोगों को, ऑक्यूपेंट्स को समझना चाहिए कि भाई ग्लास, डबल ग्लेस ग्लास, having a 10 by 10 fenestration, if it's fixed, it's equivalent to the wall. So what to say, wall only. So you can't go through the wall. So it's going to be a glass box or enclosure. So that's what the enclosure should be designed in a such a way. In terms of safety, we need to evacuate, we need to come out. So that's the design fault. I think we need to little be serious about the fenestrations and openings. So वो openings करना चाहिए हमें. See, that's what we are talking about, the CFLS, which is the Council for Fire and Life Safety, where we are coming up with the minimum requirement of the opening. You can't have only fixed glass and leave it like that. So the norms, no doubt, we need to understand, but norms also, it should be mandatory. We are making it mandatory even to use the type of glass and what. So I will share the ECSBC guidelines, which gives very clear idea to how to place the window, where to place the window, how much percentage it should be, and where it should be openable and where it should be closed. You are saying right because we are not following it, but we have to follow, sir.
Thank you very much, sir. I got it. Yeah.
अंशुरी सर आपके लिए
I'm missing Dr. Swaroop. I mean, normally, you know, he guides us very well. But anyway, inform him, and I will also talk to him. And all the participants, they are from different places. Thanks a lot.
Thank you.
Anyone have a question? Yes, Giridhar sir.
Sorry, sir. I am just muting myself. Just a minute.
अंशुरी सर,
Yes.
चैट बॉक्स में आपके लिए कुछ क्वेश्चंस हैं.
हाँ, चैट बॉक्स में है. ओके. वो सारा है. One point we might be missing while discussing with the glass becomes important even in remote to visit. He asked that question to me. I think just see if anything is there which is missing. But friends, I will try to share the written version also of my document, whatever I spoke, so that it will be very clear. And I will support it with some kind of documents which are very important while designing the overall envelope of the building, which gives you the guidelines to achieve the high performance building envelope. And civil engineers' role is very much in that, apart from the mechanical and electrical and facade engineering, because facade engineering is a very upcoming domain, which is very much, because if you see the commercial buildings, all other commercial buildings which are just outside, we have a enclosure. Inside, the entire thing is open type. Earlier government buildings and our buildings were it's a different type. Today we have a open plate system. To totally, we have a central core and outer shell. So the shell design is very important. It's not always with the glass. As Sir said, we are going to shift very fast to the traditional materials, and we'll go away from the glass and other panelings soon if we start working on that, because the shape of the glass is also matters. That's why the limitation of the glass, we are coming up with the boxes, glass boxes. But if you want to have some kind of a curvature, some kind of a different types of moldings, I think we can go for alternative materials, which are going to be very, very coming soon in terms of the material science. So I will share that and give me feedback. Over to Mr. Yogaraj.
Thank you, sir. And thank you, everyone.
Yes. Alternatively, we can use concrete stone, or we can use even the vernacular. We are using in the coastal areas the laterite stone. Laterite, it was a big stone. Today we can have some kind of a, because it's a soft stone, we are cutting it and we are trying to utilize in a different form. And see, that's what vernacular material and local material. Vernacular is what? Local material. So if you go to Shahabad, Tandoor, they use the slates for walls, they use the slates for roof and everything. And they are very energy efficient. So in terms of hybrid structures, and today we are thinking of precast structures, hybrid structures, or some kind of steel structures. I think combination of these can be done. That is what the T-hub, which is a very highly cantilevered, but still we could do it. Because of the structural system. Acrylic glass, yes, acrylic glass is also a glass, but the heat, we have to check the value of that. Heat increase should be less. So if you put a proper reflective coating, I think that is good. So opening in the glass, opening in the wall, there are two different things. Opening in the walls means penetration, you can see out. Opening in the opening is what we require. We need to have proper air change, height of the floor to height, and a stack effect. That entire thing we can learn. And building physics is very important in terms of having the better this one. Nature, yes, we need, first of all, how we need to go towards nature. The nature of going away from the nature is a bad. We need to have good courtyards. See, if you are putting indoor plants, don't put plastic plant. Throw it up. You put the plastic plants only when you open the eyes. When you are closing the eyes, if you are having the, if your nose can feel better, then better. So have some kind of indoor plants. Believe it or not, if your indoor plants, which are designed to keep in indoor, if they are not good, your health will go. So you try to maintain the indoor temperature, which is good for the indoor plants or plants, then your internal atmosphere will be good, and that is in your house. So today, have a session inside your family members. Try to maintain the health, wealth, indoor atmosphere, and then our own atmosphere. That is what inner engineering is important for our body. Inner engineering soul is required for the building also, the post construction. Thank you. Climbers, yes, that's a part of horticulture and a landscape. I have about 500 to 600 plants within my house and terrace. So we water. When you are watering the plant, also somebody said, why you are not putting all the irrigation system so that you just switch on the things, it will be planted. No, when you are planting each pot, the required water level, or when you communicate with that particular flower or the tree, that gives an entire different kind of a mindset. So some people, they have pets in house, some people they have plants in their house, but putting a pet as a doll or plastic, it gives no sense when you close your eyes. That's what I'm saying. In your house, if you are closing your eyes and feeling the same, I think you achieve it. I think we can achieve that with some exercise and interventions. I think, okay, Mr. Yogaraj, we can conclude.
Yes, we can conclude, sir. Thank you, everyone, and thank you, sir. मिलते हैं next Sunday.
Thank you.
Thank
Thanks
you, sir.
for the
Thank
opportunity.
you,
Thanks.
everyone, for being here.
Yeah.
Thank you.
Bye-bye.
Bye-bye.
Bye.